Now let's see this closure set of attributes using this one, an example. Okay. So what is closure set is, let's say we have attribute A. Now if I write A plus, if these are all the functional dependencies which we derived from the semantics of the database just by talking to the customers, then what I'm interested in is, here we know that given the value of A, I'll be able to get the value of B uniquely. That is what I know, right? And now using these all rules, given the value of A, what are the other values I could uniquely say? That is what I'm interested in. It is not just that I'll get only B. There are many more things I could easily derive. See this? Now one thing is, given the value of A, I'll easily get the value of attribute B, isn't it? Because of this functional dependency, A determines B here, right? And now because of this one, once you get the value of B, you could even get the value of D, isn't it? Therefore BD is also included in the closure set. Now with these two, can I get even more? Just say this: given the value of A, I am able to get the value of B, and given the value of B, I am able to get the value of D. Therefore I got this. Now known these three values, which means I know A, I know B, I know D, right? I can even add A also here. The reason is, given the value of A, I can obviously find the value of A, isn't it? Trivial. So anyway, now by using these three attributes, will I be able to find out any more attributes? That depends on if the left hand side of any of the functional dependencies consists of only these three. Just see this: left hand side of this functional dependency consists of A is there, therefore I have already added B, and this consists of B is there, therefore I have already added D. Now can I add this one, the whatever C determines? If I have to add D and D, I should have added C first, but then there is no way A is able to determine C, therefore I cannot add it, right? And anyway, A and B are already added, and this one cannot lead to the addition of A and B because C is not there, right? Therefore A plus is this. What is the meaning of it? It says that this particular closure set says that in any table in which you have the attributes A, B and D, that is important. In the table in which you have attributes A, B and D, given the value of A, right, you can find out the values of B, D and A. Got it? That is the meaning of closure set. Now let's see what is B plus. B plus means what are all the attributes I can find out, given that I have the value of B. Definitely I can find out the value of B, that is trivial. And what are the other things? Since you have added B, just see the functional dependencies with left hand side which contains only B. Now it turns out that this is the only FD which contains only B. Therefore I am going to add D. Right now B and D are added, then what will get added? Just see the left hand side and see if they consist of only B and D. The left hand side consists of only this one consists B, this one consists C, we don't have it, CD, we don't have it. Therefore we cannot add any further. So given the value of B, I can find the value of D only. So on any table which contains B and D, I can view the value of B and I can get the value of D uniquely. Got it? And what about C plus? Given the value of C, what can I derive? See, given the value of C, I can derive C definitely, right? And then that is going to give me DE, right? Because of this FD. And now I have CDE. Now I'll check the left hand side of all the FDs and see if there is any combination of CDEs. Yes, here we have it, and I'm going to get AB, right? Therefore, given the value of C, I'm able to get uniquely A, B, C, D, E, isn't it? So what can we say? On any table, in any table which contains all these attributes, given the value of C, I'll be able to derive all these values uniquely. Got it? Now what about this one, D? Let's say D plus. So D plus, I can get D definitely. Now let's see if there is anything I could derive only from D. There is no way D is going to give us any values, therefore D is the only thing. What about E? E plus, there is no way I can get anything, right? So I got only these values, right? So A plus, B plus, C plus, D plus. And sometimes this closure set can also be found out for a combination of attributes, right? Which means we can even find out what is the closure set for, let us say, CD. CD is over. Yeah, let's say CD only. CD plus. What is the closure set of CD plus? Then whatever is there here, you are supposed to add it because it is trivial. If CD is given, obviously you are going to get CD, isn't it? Now check for all the left hand sides which contain only C and D, right? So here we have C. So because of this, E will get added. D is already there, E will get added, right? And here we have C and D, right? Therefore I am going to add A and B, right? Are you following it? See, I am going to check the right hand sides, where the right hand side contains a combination of already existing elements in the closure. Now check this. A is also there, A is here, therefore I can add this all the right hand side of this production also. It is giving me only B. B is already there, right? And B is already there, therefore I can add the right hand side of this production also. It is giving me only D. D is already there. And C, it is already added. This one is also already added, right? Therefore, using CD, I can find out everything. See, one more thing. If C plus is able to derive everything, isn't it? From C, if you are able to get all this, right? Obviously, CD is going to derive all this. Are you following the logic? If the attribute C is enough to get unique values for all the attributes, then adding D, is going to get everything because already C is there, right? So let's say what happens with AD plus. Okay. Now AD plus means I am going to add AD first because it is trivial, and then I'll search in the FDs left hand side which contains a combination of A and D. Now if you see this, left hand side contains A, therefore I am going to add B because of this functional dependency, right? And now I got B, and B is here, and I know B derives D. D is already there. I'm not going to add it. In order to add this, I have to have C, but there is no C, right? In order to add this, I have to have C. There is no C. Therefore, AD plus is going to be ADB. Got it? So this is how we can apply, this closure properties, and the closure properties have lots of applications. We shall see one by one. Okay, so this is the, I hope that you understood it, or maybe if you want to do one more example, we shall do it. Let's say ABD plus. I want to see what will be present in ABD plus, right? So first thing is you have to add ABD, and then you have to check the left hand side which contains ABD. Now left hand side A, this is already added. B, this is already, D is already added. And what about this one? This one cannot be added, and this one cannot be added, right? Because they need C. So only this is what I got. So A plus I got this, and even ABD plus also I got this, right? Fine. We shall see various applications of this closure set. Okay.